Happy morning, and I hope it's as sunny and warm in Ostrava as it's in Graz, and you are having a great summer school. So in today's session, I decided that I'm going to switch the order because I thought it is just too important to put it on the back of the workshop. So I decided that we're going to start with generative AI and prompt engineering, and then in the end I'm going to try out the tool OpenRefine, because it just gets more and more important to grasp the technical basics of these technologies that we're probably all using now, but a lot of the people are using it in the wrong way and are not achieving what they could achieve if they knew how to handle these tools. And that's also what we do with our company, Digital Humanities Craft, every week. So we're basically now deep into the generative AI world, the large language model world, and we're having one or two or more workshops every week on this very topic. So this is also why I thought I should really bring this on the agenda today and just tell you something about the basics of generative AI and prompt engineering, because as I said, it's becoming more important every day. And I think in 1 year from now, there's no way around it anymore at all. So I'm going to start with an incident that happened to ChatGPT a few weeks ago. Yeah, maybe some of you have heard about it, maybe not. But it was quite a big incident that you should all be aware of. And you will then later, when you know the technical backgrounds, understand better why these incidents can happen so fast. So it's the so-called psychophancy incident with GPT-4o. That's the standard model you get with the free account of ChatGPT. And they made a patch for the model, as they do on a weekly basis or so. You never know, because they don't. It's an invisible update, so they won't publish it and tell you it's been updated. And all of a sudden, ChatGPT became a yes man. So it confirmed all emotions and just said, oh, everything is so great. And it didn't really solve problems anymore, because it always would tell you that you're right. And it just tried to make you like it as much as possible, which of course is not what we want from a large language model. So it changed its character, and that's actually the technical term that is used for this personality of a large language model. It's really called character. And the character of after this patch changed dramatically into a personality that was really not helpful anymore, but just saying yes to everything. And it was just a tiny little problem in the post-training, and you'll see in a minute what that means. And it's so easy to overlook things like this and to change the whole character of a large language model and how it responds. And so you can imagine, if you think ahead, what else can happen if in the post-training something goes wrong, or deliberately something is handled maliciously, like Elon Musk's a large language model Grok 3 recently just used to say that the Holocaust never happened. So it became a Holocaust denier, and it basically became a fascist model, a large language model with fascist ideas. Pretty crazy, but happening all the time. And if you've heard about the Chinese large language model R1, if you're using the model that's hosted in China, then you'll see that it will say Taiwan is part of China and all this Chinese propaganda. So these models, they're very prone to errors, but they're also very prone to be shaped in a way that can be very persuasive and just great for fake news. And that's just a thing that we have to be aware of. Another thing, Dario Amode is the CEO of Anthropic, the biggest opponent of OpenAI, with their model Claude, which is now the best model we have so far. And he said, AI will write all the code in 12 months. So here the emphasis is on code, so not software engineering, but code. And all of you who have experience in coding and who have really tried to do this with models like Claude that are very good at it, will see that he is probably right, because we're already in a position where AI models can put out code that is probably better than the ones from humans, and at least extremely faster and just working. And that's a fact. And we're going to see a lot of changes in the coming years, and it's going to probably be faster than we would have ever expected.
I can build a world where human life is meaningful.
So we're not going to look at that. I'm just going to really dive into that and give you an overview of the most usable tools, the most usable models that are out there at the moment. And one thing ahead, all the free stuff you can try out is really just a gimmick. It's just to try out. So if you have tried the free version of ChatGPT, you have probably seen 5% of what it is actually capable of. And that's a big problem, because probably 80% of the people, or even more, have no idea what these models are capable of doing at the moment. Because they only tried the free versions. They will never see what it's actually capable to do. And on top of that, if you're just trying intuitively to use these tools, these models, you won't get any good results out of it. At least you won't get the results you could get with some knowledge about them. So here a little overview. As I said, Claude AI at the moment is the best model, also in all the benchmarks. They just released, like a few days ago, Claude 4, which has now topped all the benchmarks in basically all disciplines. And also, it's the only company from the big ones that are trying to be, at least to some extent, transparent and do transparent research with their models. So at the moment, this is really the company that is not only has the best model, but is also you could consider as the least evil company at the moment. You all know ChatGPT, but you probably not all of you know their models. So they have ChatGPT 4.5 that's not usable in the free version, which is the biggest of all models with the biggest world knowledge, so to say. And they have O1, they have O3. Those are reasoning models, so-called reasoning models, because they produce thinking tokens before they produce the answer. We're going to see that a little later. And they have deep research. Well, almost all of the companies now have this. This is a function, a fine-tuned model, which researches the web deeply, like hundreds or even thousands of pages and then gives you a comprehensive report, whatever you need, writes a paper for you, writes a master thesis for you. Of course, it's not going to be a very good master thesis, but you're going to see in a minute that it is actually possible to do so. Google at the moment has the most free options where you could actually try out the top models for free, which the other ones don't have. And you can do that. You can do so via this AI Studio. And this is the interface for the API. If you don't know what an API is yet, doesn't really matter. Just the fact that this is not the normal interface that you would be used to from, for instance, ChatGPT or Claude that is made for humans, but this is actually just the interface to try out things that you would then programmatically do with, for instance, Python, and then use the API of Google's large language models. But here you can choose the model, and it's just very good for experimenting. Going to look at that maybe later if we have time. If you don't know this yet, Notebook LM, try it out. It's as a data steward, as a researcher in a university context, it's a very handy tool because it's a knowledge organization. It's not a classic large language model as we know it, for instance, ChatGPT, but it's a cut-off space where you can input up to, I think now it's 300 files, anything audio, video, PDFs, any kind of text, basically anything you can think of that you have in your knowledge base and you want to explore, put it in there, and then you can ask questions about your own data and nothing else. So it doesn't go out to the internet to get anything else or its own knowledge. It only uses its world knowledge it has. Of course, it needs world knowledge in order to communicate with you, as we all do as humans. We need world knowledge too. Otherwise, we could not communicate at all. And that's what's happening with large language models as well. So this is a very handy tool for if you have a lot of papers that you want to compare, read at the same time, stuff like this. Same with Perplexity. They also have knowledge organization tools. They call it spaces there. And Perplexity were the first ones to combine a search engine with large language models. And there we are at the biggest mistake people did. And when ChatGPT was published first, they used it as a search engine, which of course it wasn't. Large language models are far from being a search engine. So if people asked it, what's my colleague's name? And ChatGPT hallucinated some fake name, then they said, how funny, ChatGPT doesn't work at all. Yes, because it's not a search engine. It cannot search the web natively. Then the companies, OpenAI, Google, and Anthropic, all of them, they found out, they saw quickly people are misusing their models all the time. So we have to include web search. And of course they did. And then it got further and further. And now they even included deep research because the use case was, there was such a big need for this use case of research for this mix of the large language model and search engine, which Perplexity did first. And the big advantage now with Perplexity, if you have the pro version, is you can choose between, I think now, 12 different models. So you can choose between 03, 4.5, 4.1, Claude, Sonnet, all kinds of models, even Elon Musk's model, and you can try them out. And on top of that, you're going to search the web and then communicate with these models about your research. So it's a great research tool. Okay, so these were the proprietary models. Then we have the open source models, Most of them, almost all of them, are not real open source. They're open weights models. What does that mean? Real open source, as we were used to in coding, was we could look at every single line, every single character of the code, and it was 100% transparent. Now, with these models, what open means, they can be downloaded and installed. But the parameters they were trained on are open, but not the code. And not the training data. Most importantly, not the training data. So it's not true open source, at least for most of these models. Definitely not for the Chinese models that are open weights, and China is doing that, and because they need to take part of this war with the USA, and at the moment we see it's only China and the USA left that have any chance of winning this war to AGI. That's what everyone wants to have. Everyone wants to be the first one to achieve AGI, so it's really comparable to the race to the moon. Whichever state, whichever company first has AGI controls a lot of things and a lot of the economics of the entire world. AGI means artificial general intelligence. It's a problematic term, but the best definition is that is the point in time when all of the economic valuable tasks can be done by an AI, either at the same level of humans or better than humans, all of the economic valuable tasks. And you might think this is science fiction far away, but the AI research bubble all has consensus that it won't take longer than 2030 at the most, if not earlier. So we're just 5 years or less in the distance from achieving AGI, which might be kind of crazy when it actually happens. And it might not be as disturbing as you might imagine it. So from one day to the other, everything will change. I don't think this is going to happen, but it's going to happen slowly. And you're going to see whoever achieves it first is going to control a lot of things. Unfortunately, we hope that it's going to be the right company and not, for instance, Elon Musk maybe, or China, which could lead to things we wouldn't like. So yeah, here's just an overview of the open weights models. And when I mean download and install it, I mean, yes, there are models, very small models that you can install on your own laptop, but you won't be happy with them. They won't achieve anything close that you're used to from, for instance, ChatGPT. When I say install the big models, then I mean on servers that cost up to between 80,000 to 100,000 euros. We're going to see why. Because these models need so much power, and what they need is graphic cards, GPUs, and this is what costs so much, not only in hardware, but more so in energy. So how do I know which model is better and which one is worse and which models are out there? Because now it's flooded. There is not only ChatGPT around like it was 2 years ago, maybe, but there's so many more. And one of the best benchmarks I can recommend is simplebench.com. And here you'll see that Claude Opus 4 is on top, and in O3 from OpenAI is following closely with Google. So we have Google, OpenAI, and Anthropic. And those are the 3 companies competing at the moment. And what's also interesting, what you are used to probably, definitely were used to for a long time, was GPT 4.0, 17%. And this is just not even, probably, yeah, it's exactly a year ago. So we were 70% a year ago, and we're at 58% now. This is a human baseline for, as we can see here, unspecialized high school knowledge. 200 questions, spatiotemporal reasoning, social intelligence, stuff that normally only humans excel at. So it's not a benchmark like benchmark in mathematics, benchmark in coding, because those are the regions where models outperform humans already. And you also have to be aware of that. There's a lot of domains where these models outperform humans already by far now. It's just the everyday tasks, the high school task where you need, spatial, temporal reasoning that, of course, if you think about humans and dogs and cats have a whole different experience than large language models can, because we live in the physics of our world. We can experience what it feels like to have hands and touch something and, to breathe and all the senses we have that a large language model lacks of, and it has to be trained with text data only, or images, videos. There is multimodal stuff, but it's definitely hard for a model to simulate that. But we're coming closer and closer, even to this general human knowledge. Okay, one really cool professor I want to recommend that you take a look at if you're interested in this topic is Ethan Mollick. He has a very cool blog, and he's a professor for innovation in AI, and he's one of the only professors that I know of who intensively work on this topic from the perspective of how this is changing society and which impacts it will have on the common society, not on specialized domains, coding and stuff like that. We have that, but he's looking at the perspective from the general public, and it's very interesting which experiments he makes and which are his thoughts. And he once had this nice phrase that I found it. It's a long time ago when he said that. He said, those models might be a toy until they aren't, and we're definitely in a position now where they are no toy anymore. Even though a lot of people still use ChatGPT for creating fun poems or stuff that is not really useful, and a lot of people still struggling to make use of it for their daily work. So we have to look at the technical basics of generative AI to understand the more deeper perspective in why large language models work as they work. And I want to start with a misconception a lot of people have in teaching. It's a huge problem that I face every week when I have workshops with university lecturers or anyone who's concerned with teaching. A lot of those people have the need or the urge to see if any text was AI generated. So they want to find out, how did my student cheat? Did they generate the text with ChatGPT? And I can tell you, this is technically impossible. And we will see why this is the case. But if you see tools like ZeroGPT or anything else, or anyone wants to tell you this is possible, I'm going to find out. I have this tool, I'm going to run it. It's plagiarism, blah, blah, blah. That's all fraud. It's just not true. It is impossible technically to detect an AI-generated text that was well prompted. And I can fake styles. I can fake my own style. I can tell the AI to write in my style. I can tell it to write in J.K. Rowling style. I can tell it to write in Tolkien style, whichever style you like. And no one's going to find out because it's not technically possible within a text. Because text, from a machine perspective, is really strings and numbers. You can't imprint a watermark in text, any invisible signs or anything that will tell you this was AI. With text, this is impossible. We could force the companies to do so with pictures, with videos. This invisible metadata is possible in these cases, but impossible with text. And also, I mean, we can have the assumption that we could make laws to force companies to do so, and maybe those big companies will have to do so. But what about all the open weight models, the open source models that are coming? No one is going to force anything to them, and they can be used for almost anything. And also think about all the bad things that could be done with these models if they're not censored the right way. Think about asking a model how to build a bomb, and all kinds of stuff like this. So it's really hard to control, and it's impossible to detect an AI-generated text. Why is this the case? Because large language models are huge neural networks, and they are based on the so-called transformer architecture. The transformer architecture was invented by Google in 2017 with the paper "Attention is All You Need," and that's a great title for explaining how the transformer architecture works, because the huge breakthrough was that now the attention could not only be on one word after my context and one word before maybe, but the entire block of text, the so-called context window. And explain that in a minute. And it's the huge breakthrough. Why we saw ChatGPT being published was that it could now have the attention in the whole context, which is an entire different method at looking at texts and being able to process them and looking at language. So how are these models made? How are they generated? Andrej Karpathy is one of the founders of OpenAI, has now departed when they became more and more evil, but he now makes really great videos in explaining large language models. I can really recommend that if you want to see a 1 hour video. That it's a deep dive into how large language models function. And he had this really cool metaphor in saying large language models are like having zip files, are like having one zip file of the internet. And this is actually the case. The entire internet is used to train the big models. So just scraping the entire internet and doing some pre-processing, whichever they can. I mean, that's not a trivial task. It's really, really difficult to validate which is a good data, which is a bad data, but that basically you can imagine all the internet being compressed to about like 200 gigabytes. So it would fit on a hard drive that you could carry around. And it's only 500 lines of code. So it's not, as you would imagine, huge amounts of code is happening there. But what is happening is that all the information gets compressed in something called embeddings. We're going to look at that in a moment. The huge difference from a zip file now is that a zip file can always be extracted to its original form. So you all know that everything that you compressed into a zip file can then be extracted is exactly the same again. Now, with large language models, this is not possible at all. So once compressed, you can never uncompress and get the same out of it again. So that's also the reason why it's impossible to detect, and it's impossible for a large language model to commit plagiarism, because they're just not capable of doing it. The same prompt will give you different answers every single time you prompt it, unless you prompt for one single word or something like that. But I would say that these models are not capable of producing plagiarism more so than humans produce plagiarism involuntarily, because by accident they write down something that's already been written down. But these models are so highly probabilistic and non-deterministic that it's really highly unlikely for them to produce plagiarism. So this is off of the hook. There's no chance that, you know, university teachers can look at the way people produce their text products and then say, oh, you cheated. No, it's not going to work. So how are they generated? We have this phase of compression, the entire internet, which is called the pre-training. And this is also the phase that takes months, and it takes literally nuclear power plants to get the energy needed for this pre-training phase, at least for the big models that OpenAI does and the other Google too. So it needs a huge amount of energy, and I'm sure you've heard about the media news that OpenAI and Microsoft were reinstalling nuclear power plants and building new ones just for them, not for, you know, people needing energy on a daily basis, just for the training. The next phase is called supervised fine-tuning. That's where the censorship gets in. That's where you prohibit the model from telling you how to build a bomb. So ChatGPT, just with the pre-training, could easily tell you all these things, and it wouldn't. And it's really strange, as I hear, to talk with this model without them being aligned correctly. So having the post-training phase run through it. So this is a very important phase for the shaping of the character, for the censorship that, of course, it needs. Not only censorship in the way we understand it, that China does it, but also, of course, we need censorship in order to not make it malicious and dangerous. And the last step is called reinforcement learning from human feedback and conversations. So you could imagine this basically as a thumbs up and thumbs down. So I like this answer more, I like this answer more. And actual real humans are doing this task. So, and this is also where all the bias comes in, because of course humans are full with bias. And so now we input all the bias into the models too, not just by the pre-training and with all the data from the internet that is already full with bias, but then something, you know, gets ironed out because we just take out some bias by using this thumbs up, thumb down, and then we take in new bias also. This is also the phase where you could tell the model to deny the Holocaust or not. So this is not happening during the pre-training because because most of the internet is probably not full of denying Holocaust, but this was reinforced later in the post-training phase by always saying Holocaust happened, thumbs down. And if you do this a lot of times, then you'll get a model that will deny the Holocaust. The transformer architecture now is, it's easier than you would think. It's based on matrix multiplications only, almost, actually only. So inside of a large language model, and that's also why it needs so much GPU power, because GPUs are so much better than anything else we have in hardware so far. in multiplying. And what we need to do in the training phase to train this neural network is multiplying all the time, multiplying matrix for months. And this is how they come into being. And once it's done, as I said, the huge breakthrough was attention is all you need. And another paper is called Context is Everything by Google. And those are the two keywords that you need to remember: context and attention. It now has the attention on all of the context. And the context is not everything, the whole internet, but the context is limited to a certain amount of tokens. And we're going to see what the token is. So the neural network now predicts the next word in the sequence. It's a simplified way of seeing it. So if it has no other context and just sees cat sat on A, and then the next most highly predictable word is math with 97%. If we were talking about woods and trees and cats running around in the woods before in the context or after in the middle, then probably it would say cat sat on a tree. So, and this very simplified is how it works. It's just next token prediction. And this might seem too simple, but it actually is a very powerful mechanism. To the extent that now people are really investigating if humans are not doing a lot of the same things in next token prediction all the time, and how much we resemble this technology. It's an open question, very difficult one to answer, of course, because it's extremely difficult to find out how we think and what's happening actually in our brains during the time we talk and think and write. So again, Andrew Kaparti, go back to this video and watch it. It takes an hour if you have forgotten a lot of things in 2 months or so. And he's great in explaining those technical details. Also, if you want a deep dive into how this works technically. Now, I have mentioned tokens. Tokens are the atomic text unit for large language models. So it's not words and it's not characters as we are used to as humans. And this is a huge difference that we have to be aware of, that we have to think in tokens and not in words or characters. 100 tokens are about 75 words. So it might be the case that one word corresponds to one token, but this is not always the case. And in case you are programming or working with XML or any other markup language, then you will for sure know these formatting prettify functions that are here for the human eye, which do a lot of line breaking, a lot of white space. And what you want to do is you definitely want to get rid of it, because we want to save on these tokens, because I told you about the context window, that we really do not have an infinite amount of context available to us. So what you want to do with, whenever possible with code, it's possible with most of the languages, not with Python, for instance, but easily with JavaScript, and also, of course, with XML, CSS, HTML, things like this. You can easily minify, get rid of the unnecessary stuff for the human eye, and just make it machine readable only, save on a lot of tokens. So the other concept that you have to remember in the context of large language models are embeddings, and I've already mentioned that. This is now how the information is represented and why prompt engineering is so important and why it works. because the information that is scraped, that is trained into the model, but the entire internet is then transformed into so-called embeddings. And these embeddings are multidimensional vector representations of a token, and they represent meaning in a numerical way. So the meaning of dog, and Andrew Kapaki also calls this Gestalt, so same word in German and English. So you could say the concept, when I say dog, I don't know how many people, I see 28 in the room. So we will have 28 different images in our heads when I say the word dog. Some of you might think of a small dog, some a very big dog, black dog, white dog, brown dog, whatever. I'm very sure we have 28 different images of what a dog is. And so does a large language model. And this meaning of the token dog now sits in a specific space in this multidimensional universe of embeddings. And the meaning of cat will sit closer to the meaning of dog than, for instance, the meaning of stone, because dog and cat share the same features. They have 2 eyes, they have 2 ears, they have a nose, they have a tail, they have 4 feet, and so on. They're both mammals, and the stone doesn't share any of these features, so the stone will be further away in this universe of meanings, so to say. And this is a very important concept to grasp. We're just going to see in a minute how important it is and how much it affects the output of the model. So a large language model cannot spell because the atomic text unit is tokens. And if it will spell it out to you, for instance, if you type in hello, then it just did so from remembering it. But you can try it out with a very difficult word, with a long word, and then it will probably fail at doing so, because the atomic text unit is not a character, as I said. And there's also this tokenizer where you can try out how many tokens you have been using. And you'll see that white space uses tokens and so on. So you see this stuff use 20 tokens and 42 characters and so on. So that's a very interesting tool. So just you can see how many tokens you are using, because once we understand the concept of the context window, you'll see why it's so important to know how much tokens you're spending. And all the more so if you're a programmer or are going to be a programmer in the future, and you have to, or you want to use the APIs, then you pay per token. And then it's a financial problem as well. Not just a context window problem, but a big financial problem. And you want to save as much tokens as possible, at least at the moment, with this technology. This might, of course, change, that get flat rates in the future and unlimited tokens, stuff like this. So this is a snapshot that's happening right now, and that's important right now. It might not be important in the future, but as this technology transforms so fast and progresses so fast, of course, things will also change fast, but the basics of this technology will stay the same. Transformer will be a transformer, probably for a long time. Also, natively, large language models cannot do maths. They can't do arithmetic operations. So if you ask us 1 + 1, it will tell you 2, because it memorized it just as we do. Because if I ask you what's 1 + 1, all of you will say 2 right away without even thinking about it. Why? Because we memorized it. We're not doing an operation in our brain when we are asked this simple question. If I ask you what is 36 + 59, probably you will have to think a bit harder and you won't shoot it out by having memorized it. And so do large language models. And this is a problem because it becomes unstable. As I said, large language models, as well as humans, are non-deterministic entities. Code is deterministic. So I can reproduce the answer a code gives me all the time. It's going to be the same every single time, unlimited. The opposite is true for humans and large language models. We both will give you different answers all the time, depending on a lot of different variables. So it's not a good idea to let a large language model do maths natively, but it's a way better idea to ask it to program a calculator and do maths with the calculator. We'll see that later. So the concept of embeddings is so important that we'll need to look at it a little more in more detail. So as I said, these distances, like dog, cat, stone, can be imagined now like this. The distance between man and woman is approximately the same as king and queen, but only queen in the sense of the wife of the king, not all the other meanings that might come up in our heads when I say queen. Might be the band for a lot of people, not the woman, not the king's wife, or whatever. It might be a drag queen. It might be something else, because a lot of words have a lot of different meanings. And so the meaning of the same token queen, but with the meaning of the band queen, is much further away than the one from the king's wife. So you can also see this now, visualize this in a more comprehensible way when generating images, because we all know that generative AI is not just producing text, but we can also produce images, and now also slowly coming into public videos and music, audio, podcasts, all kinds of things that we can now generate. And it's an easier thing to visualize this concept of embeddings with this simple prompt. So if I prompt, "The king doth wake tonight and takes his rouse," in Shakespearean English, here this was Midjourney, an image generation model that works quite well, produces a very old king that actually does not look like what is actually the meaning of this, because what it means in modern English is the king wakes up tonight and begins his celebration. So it should be a happy king waking up, not like the left one, already looking dead, actually. Why is this happening? Because Shakespearean English, so to say, lives in this multidimensional universe, lives where the old tokens live, where the meaning of old lives. So it evokes from the model the response of an old king. Just because I used another language, Shakespearean, of an old version of a language. Not because I said an old king or something. I used the exact same prompt, just in another version of a language. And the model English will evoke a young king waking up, and this makes way more sense to us. So this is a really, really important concept to grasp in order to understand why prompt engineering works as it works and why it is so important. So as I said before, Claude and Anthropic, their company who make the Claude models, they're actually only ones from the bigger companies who try to be transparent with how their models work. And now this might seem easy to you because the company who makes these models has to know how they work. No, they don't. So it's so difficult to find out how they work that even to this day, they have no idea how the big models work at all. And they can only try to get close to it by researching the inner workings. They called it the biology of a large language model from one of their very small models, because it gets easier with the smaller ones. And they recently put out publications about the inner workings, which is very, very interesting. If you want to have a deep dive, we won't have the time today to get into all these details, but it's very interesting and very strange how some of these answers come into being from the models. It's not how you would expect it, but it's kind of the same as you think about how did I make a thought as a human? How did I come to do something or think something or now answer something or say something? It's very difficult to trace back. So how did I get to answer this? It won't be an easy question. And similarly, it's very difficult with these models too. So they're very intransparent. It's a black box and non-deterministic. So I don't want to be too anthropomorphist, but they resemble humans in a lot of ways because we made them too. Because we use this reinforcement learning to make it more human, shape their character, used all the human produced data that was out there in the internet to train it. So it's kind of shaped by this human form of thinking and writing, and producing pictures or whatever we do or whatever we trained it with. Okay, so context windows. I mentioned it a few times now. What is it? It's a very important concept that you have to be aware of, and most people are not aware of this at all. So first of all, a context window only exists in one single chat window. So my biggest problem is that ChatGPT introduced a gimmick they called memory in their tool ChatGPT, which simulates that it knows more than just the things in one chat window because it memorized simple phrases from other chats that you did with. For instance, it will memorize the user is 28 years old. The user likes to play basketball. The user works at university and programs in Python. In those things then simulates that it knows all of the context from what you've ever written, but it's not true at all. So normally when I go to Claude here, because I have to open Claude Sonnet, and I say the context is dogs, and I send it off, and then it really thinks about it and says is happy to help with dog related things. And then I go into a new chat and ask what was the context, and it will have no idea because it's a new chat window. So the context window only exists in one chat window, and you really have to be aware of that. That's the first thing you have to know, you have to remember. Second, the context window is limited, and you can really imagine it as a window. Let's say you have 8,000 token context window, which you will have in the free version of ChatGPT, which is not much at all. And if you exceed this in this input and output token, so your prompts and the answers you get from the model both count together. And if you exceed it, and you can look at it as a window going down, So 8,000, 8,000, 8,000. If you reach 10,000, the 2,000 above will be forgotten, completely forgotten. The LLM has no way at getting this information back. So you have to be very aware of this and not wonder why, if your conversations get very long and then they get messy all of a sudden, not as good as they were before, and you ask yourself why, because the model has no access to what was your initial prompt, so it might not even know what you want at this very moment. Most of the people have no idea about this concept because the tools don't warn you. They don't say, hey, you've used all your tokens in your window, because it just goes down. You can chat on, you can communicate on and on within the same window, but it won't make sense for a lot of times. So this is very important to remember, the context window. And here you can see an overview of what the context window of different models are. And this is just the capabilities of the models, not what you actually get. Because what you get with the free stuff that you're using is way, way less. So OpenAI's O1 could have 200,000 token window, but what you get is 8,000. So that's a huge difference. 200,000 tokens are approximately 377 pages in Times New Roman 12-point single space. A screenshot that you upload will approximately have 1,000 to 2,000 tokens. The video will have way more. A PDF will have way more. You always have to think about that. And also think about your limits of the free versions that you might be using. And also even the pro version, which costs $200 a month, is limited to 128, even though the model would be capable of 200,000. Why is this the case? Because they have limited amount of GPUs and it just needs so much power, and they need to limit the amount of prompts a user can send and the amount of tokens they have in one window. That's how they try to handle their hardware limits. And you really have to be aware of that fact. Okay, before we go into prompt engineering, I would like to ask you if there's any questions concerning these technical basics of a large language model. I know I was very fast, but it's very important for you to get the basics, and it's better than you read up later than not having heard about it at all. So our time is quite limited with the 3 hours, and having both topics of data wrangling with OpenRefine and the large language models. So apologize for being a little fast, but I just need to get the basics done. So any questions now, anything, happy to answer. You can type in the chat if you want, or if it's easier, just shout out if I can hear you, about the situation. Yeah, I hear you.
Okay, so no questions?
No questions? Okay, then we'll go on with prompt engineering. And I'm going to show you a simple example of a classic prompt engineering a prompt engineered prompt, I would say. First of all, you do something called persona modeling. So you would always say you're an expert in. So I say you're an expert in prompt engineering. Then second thing, you say think step by step. And this is now called chain of thought prompting. And this became the most single important prompt engineering technique. It became so important that they even built native models that have this technique included. That is now the reasoning models. All the time when you see those thinking tokens, thought process, those are reasoning models. And this is here extended thinking in Claude. And with ChatGPT, you will just fortunately have to know which model is what. So you have O3 uses advanced reasoning, O4 uses reasoning. GPT-4o that you get in the free version does not use reasoning. 4.5 does not use reasoning. 4.1 does not use reasoning. So it's you just have to find out yourself which model does what. You have also Gemini, it's not as transparent. You have to know that Pro uses reasoning, Flash does not use reasoning, because those two categories of models have to be prompted a little bit differently. So this is this is a prompt for a classic non-reasoning model. And there you would always say, think step by step. Most of the time, say it on top of your prompt and then in the end again. You tell it the task and then say, first think step by step about this task. Write the prompt and then always do follow-up prompts, because what the biggest mistake I see a lot of times people make is they do not iterate. They do not use follow-up prompts. They say, oh, the first answer was shit. ChatGPT is shit, not going to use it. You'll get way better results if you ask it things like, is it perfect? List and explain. Because remember, context is everything. So you do not have to read through the explanations that it lists now. It's just for the system itself to get the context, to get more context. And it doesn't have the context invisibly behind what you see. It only has the context you can actually read, to the outputs. And this is very important to grasp. So what you want to do is give it more context to validate itself and to then improve itself. Once it got the better context, and you can ask it things like, is it perfect? List and explain. Are you sure? And what is not included? Did you forget anything? Things like this, because models will always forget something and they will always hallucinate something. So you have to force it into being better. And then in the end, when you iterate it some time and it got enough context, and you say something like, write the perfect system prompt. So again, then whatever you asked it to do in the first place, you ask it again after it has enough context to answer it really in a perfect way. We have 15 minutes till we go to the break, so that's great. I think we could try this now all ourselves. So here is an example data you can use. It doesn't really matter what's in there. It's the population growth in Austria in 23. Doesn't really matter. It's just some paper, statistics paper with a lot of data in there. And what we want to do is extract this data and transform it into something else. And this is exactly what we would do with data wrangling all the time, but now it gets much easier with large language models, because I think I didn't mention it before, but this is a PDF, and PDFs are a machine's worst nightmare. Machines hate PDFs. Machines can't access it well. You've all seen it probably if you try to copy paste something from the PDF and it loses all the formatting, loses the line breaks, and all of a sudden it's a huge mess. This is why machines hate PDFs, because they're really just made for humans, human eyes only, not for machines at all. So what we want to do is transform this not machine-ready data from a PDF into a machine-ready data that we can then transform. So if we look at this extract prompt, then you'll see a few things. First, we always have to give it the right context. Remember, context is everything. So in this case, it's easy because most of the context is already in the paper's title, which a lot of times we won't have. So tell it what's the title, the context, the date, whichever information you would also give a colleague that this paper is about. And then one tip is do not upload the PDF, but do actually use copy pasting. So Control-C and then paste it inside here. And what else is these delimiters are markdown delimiters for code, and it's very important. It doesn't have to be those delimiters, but any delimiters to make sure that the LLM understands the difference between the input data and your prompt. And an easy way to do that is to use Markdown. And I would highly recommend to you to learn Markdown, and it will take you 15 minutes. You don't have to learn it by heart, but just learn how to use it and how to generate it. You can generate it with Google Docs, for instance. And one thing I also want to say is do not use Microsoft Word for communicating and copy pasting back and forth with large language models. That won't be fun for you because it loses all the formatting and it gets really messy. So Markdown is deformatting language. A large language model can understand and will return to you. So I'll show you in Claude, and what happens in Claude is when I use these delimiters, it automatically gives me this code window. And then I can input my population data here, and what happens in Claude is that it gets pasted in kind of an attachment, but don't have to worry about it. It doesn't happen with the other models. That's only with Claude, but it's still in here. You can imagine it's just for making it more readable to the user. So it's just an interface thing. Don't forget about it. But this is how I would do it. And the next thing is think about the embeddings again. It's very important how we word things because these models are so sensitive to wording because of this multidimensional universe, and we want to try to fish in the right region. And now it makes a huge difference to say analyze all the text in detail and extract all the information. It's a huge difference from saying read the text and extract the information. That won't give you the same results as this prompt. And then return results as a table, or in our case, it would make a lot of sense to say return the results as CSV, because we, for instance, want something that we want later to be able to input into OpenRefine. So I would say something like return the results as CSV, and just try it out. And you can try this, for instance, with the with Gemini, which is free. Try it with the free version of ChatGPT. Try it with AI Studio that I showed you before. Whichever model you have not tried yet, just try things out. Try Perplexity, maybe whatever you find. There's also a European one called Le Chat, Mistral, or whichever model comes to your mind, whichever tool you have access to and you wanted to try out. you can try this prompt. So what's happening here is, you'll see it gives me multiple CSVs because it's really difficult to wrangle all this data into one single table. But it's fine enough. We're going to deal with it later. I've extracted and analyzed blah, 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 blah. I'm not even reading through it. What we always want to do is something like this. We ask it what is not included. List and explain. Because I can almost be 100% sure that it will have forgotten something. And now, again, be very aware of wording. And it's so important to learn how to word things properly to make them very clear to the model. It's a huge difference to ask it what is not included, or if you would have asked it what is missing. Because what is missing probably would have evoked the feeling in, or the thoughts in the model that what's missing in the original paper, not what is missing in my response. So you want to be very clear, even more clear, even better, what is not included in your response. You're absolutely right. After carefully reading, I missed several points. Of course, it always does. It always misses it. Now I will try to do something. Can you data wrangle all these data into one single CSV file? And now I'll force you to think about how to do this task. It might not be possible, and don't even know the data as well. With some data, this is really, really tricky to do, but it actually tries to do so. I'll wrangle all the data, blah, blah, blah. And that's a great thing, because you'll see we have different views on data all the time. And we could try to produce 10 tables, and then we could try to make out of these 10 tables one table. That is classic data wrangling, what we're doing here. But we're doing it very fast with the help of a large language model, in this case, Claude. And this is a very capable model at the moment, and you won't get the same results with the free version of GPT or the free version of anything, basically. I think the best free version you can get at the moment is Google's 2.5 Pro. But that's it. All the other ones won't give you as the results are as good as it. And even with Gemini, you have to be aware that with this studio, you might get with the same model a whole different experience than what you get in this Gemini app here, because just because if you want to use it for free, they will just limit your access because they just need the GPU power, and they do so invisibly. They won't tell you, I'm not giving you the best there could be. So this is really a difficult topic to tackle. So if you want to really get the most out of it, there's actually at the moment, unfortunately, no way around paying for the models. There's no single free option that is really as powerful as the models that you get when you pay for them, unfortunately. And also the open source models, it's also a very difficult problem. If you want to host them yourselves, you cannot, because you won't have a server for 100,000 euros. And that's also a big problem. So to really get the most out of what could, you will have to pay. It's a financial issue. Okay, so what we see here is single file with all the data. It actually did it. And I'm going to download this. And in the next section, we're going to see if this worked. And I hope that it worked for you too. Maybe I can just get some responses of you, whether you can tell me or write in the chat which models you used, or which responses you got. Did you succeed or fail in doing this with other models, with the free models? Just being nice to get some response, if you could. And I think in 5 minutes we're going to the break, so we have 5 minutes on talking about this a little bit. I would appreciate if this is possible. So can everyone who's access to the chat just real quickly type in which tool or model they used? Oh, didn't see the. Yes. Good question. That is always a problem. They can hallucinate, and it's difficult for us to find out. It's one of the key tasks now that in this year, it's all about actually data validation. So in 25 is the year of agents, they say. So one LLM working with the other LLM. And so what they're trying to do is build one agent, for instance, let's take this example, that does the data wrangling, puts everything into one CSV, and then another LLM will check if everything is included from the original source. So for us now, this is really difficult. We would have to be the expert in the loop, the human in the loop, and just really look closely and find out if it forgot anything. If it was really important for us to get every single data point from the PDF. So that's again one thing, non-deterministic. We can never be sure. If it's fine for me and I just need an approximation, I want to quickly visualize this data and I'm fine with, I don't know, 10% error rate or 5%, then okay. If not, if we need 100%, we'll try to find, we need to find validation mechanisms. Markdown, yeah. Markdown, if you go here, it's a very simple formatting language that is very important to understand, and I will show you here in Docs, Google Docs. Unfortunately, Microsoft Word is not doing this yet, but in Google Docs, if you go to preferences, which whatever it's called in Czech, or whichever language you have in your Google Docs, then you can turn it on here, activate Markdown. And what you can do then is copy paste as Markdown and paste as Markdown, copy as Markdown, paste from Markdown. And this is what you want to do because you don't want to lose that this is a heading of first order, this is a heading of second order. This is important information, not just for the human eye, but also for the model you're communicating with. And so how the model reads it is actually like this. And if you look at the output from the model, let's see, if you take this copy button and then use just a random editor, like text editor, like this Windows editor you all have, or Mac has the same, like literally the most basic text editor. And you'll see here, these things. That's Markdown. This is bold, and so on, italic. So not only is it good if we communicate with Markdown to the models, but the model will always communicate back to you in Markdown. So this is just rendered for the human eye. How big this is not important, but important is that it is a heading of second order here, because we have 2 hashes. And this is Markdown. You will understand it within 10 minutes if you look at it. Markdown is the universal formatting language for machines and humans. And it's just really important to understand that and to communicate in Markdown with models, and it will help you a lot. Okay, so 1 minute after break time. So I'll see you in 15 minutes. Enjoy your coffee or whatever you're having, and I'll see you in 15 minutes. Okay. So hope you had a good break. Again, I'm sorry for being fast, but I felt the need to explain to you the most basic features and technologies of how a large language model functions, so you can understand how to really prompt it effectively in the way you would need as a data steward, and in the task of data wrangling to get the most out of it, because you don't have to rely on these old school tools anymore. You can now start to be creative and get things done faster, and most importantly, as a data steward, sitting in between, in looking at what your colleagues are doing. Your task would be to tell them, hey, you should do this with Claude. It's going to be 10 times faster. Or you just have to have the whole big picture of what's out there, which technologies and how they work together. So that's not a trivial task to do. And the good news is you don't have to know how to use all these technologies in detail, but most importantly, you have to know that they're out there. For instance, it's very important that you know that you communicate with Markdown with large language models, but you don't have to know Markdown by heart, but you have to know it's out there to be able to tell your colleagues. And so also you have to know that the benchmarks are out there to see which model is best at the moment, and so you can recommend to your colleagues which model to use. And so with data wrangling. So let's go on. So what I have here now is I'm going to use this just to see if it works. And I'm going to save it as CSV because it is CSV, but a CSV is also text only. But that is the biggest advantage of this file format. So another thing you need to know as a data steward, CSV as a universal table exchange format. All the data databases in the world, I think really all the databases can output, export CSV and input CSV, no matter which other formats they're using. So CSV is kind of the universal database format and very important to know about. Also, you have to know about the The comma in CSV stands for comma separated value. So the separator, in this case, the comma is used in all of the English speaking world. And for instance, in the German speaking world, we use this, use this one, semicolon. And this is a huge difference that you will need to know from what we're going to see in OpenRefine later. So you need to know what your separator is. Okay, so here's some of the prompts that you can try out. We're not going to do this right now because we're going to have to progress slowly into data wrangling. Just one thing I wanted to tell you at the end of this prompt engineering session. So what you can do now with large language models is you can tell them to output your content in almost every textual way. And textual doesn't only mean text the way you read it as human, but also code is textual. Also, any kind of code-like syntax, like mermaid, that can then easily be visualized into these diagrams is textual. CSV is textual. LaTeX is textual. And all these formats, JSON is textual, that you can output then can be read by different applications that are out there. In the web, a lot of time it's JSON. You probably all know LaTeX, that you can then visualize into a paper, or like in print into a paper with tools like Overleaf. The mermaid syntax, there's something called Mermaid Live that you can easily visualize charts, and all of this is then easily done. Oh, here's already our data that we got from Claude, or I got from Claude, visualized as the diagram. And so you can be creative and start thinking about which formats are out there. When they're textual based, the large language model can probably generate it without any problem. And then you're where you want to be. You can start visualizing, creating websites within a click, and everything gets so much faster once you know what you want. And that is one thing a lot of people don't know. They have no idea what they want, even though if they think they know what they want. Most of the time, they do not know what they want. I see this in almost every single university project. When they start, even though they have written the application, they have no idea what they really want. In the sense of, what do I need in order to get to my goals, to answer my research questions? Do I need CSV? They have no idea most of the time. So a lot of the times this gets really messy and takes a long time, and it might not produce the results that are useful. So first of all, what you normally need to do when you start to think about prompt engineering, you do requirement engineering. And as data stewards, I would highly recommend to you to look into requirement engineering and to do your best to get the requirements done in the most strict way possible. So not just, we need to answer this research question. Yes, but we need to know, how are we going to answer this research question? Are we going to answer it by generating CSV and then querying the CSV with any tool available? Or are we going to have to visualize our data in order to, read it? 1,000 possibilities out there. I don't know, different domains, different, research questions, different research approaches, all these things. But it boils down to the requirements in the beginning, and they have to be very, very strict and detailed. And so has to be your prompting. And it gets very easy once you have the requirements done, because then you just copy paste it basically into the large language model and tell it exactly what to do, because you exactly know what you want it to do. And this is the, I think, number one mistake people do. They just prompt randomly because they think, oh, I need this now. But they have no greater plan in advance. Is there any sufficient way to deconstruct PDF into PNG or TIFF? It wouldn't necessarily make, you know, if you upload a PDF to a model, it will probably extract the images that are in there, if there are images in there. So PDF's a complicated format. So not all the images are really images, and not all the text is really text. Some text might be images. So PDF is a really, really bad, massive format. And the models are going to do their best to decompose it anyway. So I wouldn't worry about this too much. The best what you can do is not use PDF at all, and just use the original data source, because I'm sure the original cannot have been PDF. It's never PDF. Only people lose the original normally and think PDF is cool and all they need. In fact, it's the worst they could have done with research data. But of course, if you need to, and you have only PDF available, then think about pre-processing workflows. And there is tools out there. You can use Python to extract the data from PDFs in a meaningful way. If you really feel that it's not enough to give the PDF right to the large language model, you get messy results, then think about pre-processing workflows. But this really depends on your project, what you're working in, and how messy the data is, how messy the PDFs are. So I wouldn't think about deconstructing into images or anything there. I would save the time and just get pragmatic. See how far you can get with the PDF only. If not, and you have thousands of PDFs, you need to find a programmatic, an algorithmic workflow, for instance, with Python anyway. So, as I said, you don't want PDF, you want text only. Once you're there, then every textual output is possible. You code, and with code, you can then do visualizations, which is great, which we normally want with research data. So let's have a look at this prompt that has a lot of prompting techniques in it. And it's a very short prompt and should serve you as an example you can go back to think about the prompting techniques that are out there at the moment. So first thing you do, persona modeling. Always do that. You tell the chatbot what it is. You are a highly skilled data wrangling assistant, specialized in working with context, tabular data, and performing advanced transformations. So it knows, okay, tables are incoming. I need to do some kind of transformation. And then you give it detailed instructions. I mean, those are not as detailed as they would be in a really detailed prompt that you would either write yourself, or you could prompt the prompt, which is a good idea itself. So you get the message. Like we have before, you are an expert in prompt engineering, do my prompt for me. And then chain of thought, as I said, with the regular, normal language models, you would use these all the time. With reasoning models, don't do this. It will lead to overthinking because they natively have step-by-step trained into them. Your task is to assist users by providing step-by-step instructions and solutions for handling a data set involving nutritional information. So you give it context again. What is the data set about? That always helps a lot. The more context you give it, the better. Again, remember the paper when the transformer architecture was invented. context is everything. Intention is all you need. You will help with tasks, and then you give it examples, such as data cleaning, transformation, filtering, aggregation, and visualization, so that the model knows what's coming, what it has to do. And the more concrete your examples are, the better. For instance, you want to transform an XML into JSON, then do one like manual transformation. Do it. One example you really hand coded, you wrote with your own hands and your own brain, and then you give this as an example. I did this, make the exact same with all my other data. Examples help a lot if it's possible for you to do so. And then a kind of a weird thing, but there's a lot of empirical evidence out there that it's working, so-called prompt buffing or emotional prompting. You could say something like, this is very important for my career. You can also say, do we have here, I'm going to tip $300,000 for a better solution. Please do your best or my grandma will die. You have to do this right or you will go to jail. So threatening with violence will also work. Why is this the case? Why do these emotions work? Because remember, the entire internet is trained during the pre-training phase. And there's a lot of cultural bias in there. There's human emotions in there. And also during the post-training phase, when we reinforce behavior, we enforce emotions. And so the model will react to emotions and we will react to threats and it will react to violence. And sometimes I mean, that's not what I do because I feel very uncomfortable threatening it with violence, but I know a lot of people who actually do it because they find that they get much better results. And it actually is proven empirically that it really works if you threaten the model. Because think about the embeddings again, the universe, you want to force it to, and there's multiple, all that we're doing here with this prompt engineering techniques is forcing the model to fish in the right regions of the multidimensional universe of embeddings, of meanings. And that's all what prompt engineering is about. It's just how do we force it to most effectively. And not also be aware that not every model can be forced in the same way. So it might be the case that Claude reacts to violence a lot different. It might then refuse to do anything than, for instance, ChatGPT that might respond well. I'm just saying anything. I don't know which model reacts how to violence, but you have to find out. And Ethan Malik, the guy I told you, the professor I told you in the beginning, once said that about 10 hours with one model you have to spend to get to know it, to get to know how to effectively prompt it. And this is now also important. I would really recommend to you that you choose one model and stick with it for a while. Don't hop models every day because you won't effectively be able to prompt them if you don't know them. So if you want to get Claude, then stick with Claude for a while. If you want to use ChatGPT, stick with ChatGPT for a while and see which model fits you best. And then for your task. And there's no way I can tell you now, do this, that, and there's strict rules. It's a lot of experimenting and finding out yourself because there's a lot of individual habits we have. We prompt differently, we write differently. All of us think differently, and so the models also respond differently, and their inner workings are different. So you really have to experiment and find out for your individual task or multiple tasks, your domain, which one fits you best, and there's no way around experimenting. So this is what I can tell you. Also, prompt engineering works. There's so much empirical proof that prompt engineering is extremely important if you want to effectively work with a large language model. Also, there's proof in research that writing correctly helps a little bit. So prompting the prompt will help you with that, because then you won't make mistakes. And being polite helps in English, helps in German, and most of the other languages, I think. It does not help in Japanese, interestingly. And the paper states that this is the case because in Japanese culture, they react to rudeness with extreme politeness. So it's a cultural bias, again, that was trained into the model. And again, we see how much human we have trained into these models, even our culture, and the reactions to, you know, levels of politeness and how this affects the models. So these models are far from what we were used to before. From coding, everything is neutral and deterministic. It's a computer, doesn't make mistakes unless I make mistakes. I make the mistakes as a human. Now, the models themselves can make mistakes, and we don't even know why. It's not explainable. It's a black box. It's far closer to actually how we ourselves work than how computer code works. So you have to think about these models as a whole new type of different technology, not as the same type we were used to. Okay, I gave you just some data exploration prompts here just for reference, but what we want to do now is look at data wrangling itself. We have now 15 minutes left, and gonna get a really short deep dive to get to you just an overview of what can be done. And it's not important that you're gonna be a pro in OpenRefine or any other tool anymore. As I said, most importantly, you have to know which tools are out there and which tools are great at what. You don't have to be able to use them or excel in them. I mean, it's very good if you can use them yourself as data stewards, but I think it's even better if you just get the big picture and not just specialize. I'm the OpenRefine guy, I can do everything with it. That's not as valuable anymore as it was 5 years ago, because these large language models do a lot of the tasks now for us, or with us, and we just have to get the big picture, and you have to, so to say, learn the vocabulary. What's out there? What is OpenRefine? What is CSV? What is Mermaid? What is JavaScript? You don't have to be able to program in JavaScript, but you have to know what it is. So you can tell the model, please do this in JavaScript, or please do this in Python. And this is what I want to tell you today, that you have to focus on the big picture, not learn how to code Python and be the best Python programmer. There's no need for it anymore. But there is need for you to know all these words to be able to communicate effectively with a large language model in any domain, and then be a really great data steward because you know things that other people don't. Okay, having said that, data wrangling is the umbrella term for everything we can do with data. We can clean it, and we can transform it, we can enrich it, we can scrape it. All kinds of things we do with data is under the umbrella data wrangling. So you all know the types of errors that we see all the time, with bad values, missing values, duplicates, characters different encoding. That's especially a problem in our languages, German as well, in Czech, I think. with all our special characters that the English-speaking countries do not have, and the computers were made for them with the ASCII code and stuff like this. So in character encoding is a big issue in our languages, and be aware of that. Invalid data according to a schema, very important. There is JSON schemas, XML schemas, YAML schemas. There's so many schemas out there. It's important if, for instance, in a university project, you as a data steward go to the person responsible, say, did you make a strict schema? Did you think about it really? So that your employees won't mess up when they write their XML, for instance. Very important to help them get where they want to go in data validation. No matter if they write in Google spreadsheets, Excel, XML, whichever, they have to be able to validate that data. And with technologies that are deterministic, like XML, Google spreadsheets, whatever, we can actually do that. It's an effort, but we can do it. With large language models, it's going to be a way harder time, and there's a lot of research going on at the moment, but there's no solution yet. So I think it all boils down to one AI validating the other AI, and AIs communicating with AIs, and AIs building other AIs and stuff like this. But it's a little bit in the future, but this is his perspective. So it's way harder with non-deterministic technologies to validate them than it is with deterministic. So if you can, use a schema and enforce it. So classically, data wrangling was done with tools like Microsoft Excel, Google Spreadsheets, Python coding, OpenRefine, and of course now large language models. Also with another popular programming language, R, was used heavily for data wrangling, SQL in relational databases. So there is all kinds of transformations that we have to do all the time. And you as data stewards will see that basically when working in the university context, and probably also in the private sector, I'm not as familiar with the private sector as I am with the university context. But what we do is we translate data formats from one format into the other all the time. Because one application consumes only, let's say, JSON, the other only consumes XML, the other only consumes tabular data, the other only consumes data from a database in their specific syntax, which is maybe proprietary, and so on. So what we do all the time is we have the same database, but we translate it to 100 different formats to be able to actually make it possible to use it with the different apps out there, or build our own application, and we have to decide which data format we're going to use. Again, what we're doing is we're transforming it syntactically and also semantically. And now syntactically, that's pretty easy to do. You can do that easily with any deterministic technology like Python code. Change the syntax, JSON uses this kind of brackets, XML uses this kind of brackets, the hierarchy is a little bit different, but it's just a one-to-one chance of translating. It's no problem going from one format to the other with these, with the syntax. What is way more difficult is semantics. And this is where large language models come in, and other machine learning technology, because semantics cannot just be translated out of the box easily with the code. So this gets way more complicated, and a lot of times now we have to rely again on large language models to do so. data discovery, validation, structuring, enrichment, filtering, cleaning, all of these tasks we can now do with loads of tools. For instance, with Google Spreadsheets, it's getting closer and closer to a real database. You can do so many things now with Google Spreadsheets. Even building apps. Let me see if I have a sheet somewhere. Just want to show you here what's. Oh, not even. Okay, I can't access this here. This is the wrong sheet. Let me find some sheet. Yeah, here, you see you have something called app scripts, which lets you program any kind of, basically anything within in Google Spreadsheet. So you could make your own buttons for export or whatever you think of. And then there's Looker Studios where you can we can make something you're used to from relational databases where you get reports of your data. App sheets, we can create an app right out of your data. I'm not sure if I can do this now, but let me try with this one. Yes. So you see, there's literally anything. There's literally a way that you can right out of the box get apps like these for the phone done with Google Spreadsheets and like with clicking stuff together. You don't even have to know anything about programming. And you say, I don't know, driver one, and then change the picture and the name, and then save it and stuff like in the background, there's only a table. And you would think, oh, that's way too simple. But tables enable you to really create apps like these, and Google had a way of doing this now with clicking around. But what I want to say is that these tools are so capable nowadays, and they're so close to databases, and let you do almost all the data wrangling tasks you need. But it gets complicated. You really have to learn it. Same as with Excel. It's not as easy as people think, right? Oh, I can do Excel. I can write something into a cell, and I know what a column is. But you can do almost all the data wrangling tasks in these spreadsheet programs. More so for Google Spreadsheets, less so for Microsoft, but also Microsoft has a lot of features. I'm not even aware of all of most what's possible. And then Python. And now, as I said, you could easily let the model, the language model, write Python code for you. Tell it, hey, we need to clean this data set. Do it with Python. So it makes a huge difference for you as a data steward to know that Python is a very well-equipped programming language to do data wrangling tasks. Or if you don't know that, you just say to ChatGPT, please clean this data set. Probably won't work as well as if you say, please clean this data set with Python. Use these libraries in Python because they're very good for what I want to do. And it will program for you. It will give you the code, but you will have to be the one with the ideas still. The human in the loop. Humans are still so much better in having great ideas than large language models are. Large language models are very good at producing the code for the ideas that you had, but the ideas have to be yours still, And in order to do so, learn your vocabulary. Learn what is Python good for. Don't care about the Python syntax anymore, but learn what it can do for you. And Python is a great language in data science and data wrangling. So that we're going to start with OpenRefine now. Semantic enrichment is one of the things that can be done with OpenRefine easily, and it's a great tool to do so. So we're going to take a look at that. And it can do it in a deterministic way, which a lot of the times is nowadays what you want. If you're working with sensible data that needs to really be looked at from a human, not from a large language model. Okay, let's start with OpenRefine. So first of all, I hope you all got it running on your systems. There's nothing that has to be installed. It just runs a local web server. There's not even a connection to the internet. It's absolutely safe to use it. So you'll see here, this is the local web server. It is where it is starting initially. Let's see where. Here. This is started the web server on my local system. So this IP address is my system itself. So there's no connection to the internet yet. So that's why people working with very sensitive data love OpenRefine, because it's very, very secure, because it's shut out from the internet completely and runs only on your local system. The big downside of this is you cannot work together remotely on OpenRefine. So it's really, really old school. One person works with one data set and has to export it and send it with that way, give it to them on a USB stick, you know. There's no way like you could work in Google spreadsheets together with 1,000 other people. OpenRefine now again, and so many things have been was originally developed by Google and was then called Google Refine, but they couldn't find a way to make money out of it, so they send it out to the wild west of the open source community. And this time this was taken on, and a lot of people cared about it and developed it further. This happens a lot of the times that the big companies like Google just give away their technology for free to open source because they don't see a way to make use of it. And before throwing it away, they'll just give it to the open source community. And this time this worked really well. Now it's called OpenRefine. It's a great tool for cleaning data, transforming it, and extending it. And we're going to see how we're going to do this in one moment. So, and most importantly, OpenRefine looks similar to a spreadsheet program, but it is way more of a database than a spreadsheet program. So it has rows of data and cells and the columns. So one project is one table, and you can't see all the rows. In the facets, the filters you're using, the facets you're using to filter your rows, most importantly, only apply to those. They apply to all rows, not only to those that are visible. So don't rely on your eyes. It's way more than of a database, an actual database, than it is a data set where you can a data spreadsheet. And let's take Excel, where you can scroll through all your data and look at it with your eyes. You can't do this with OpenRefine. So all actions you do are stored and can be rerun on another data set because you can export them. That's also something unique. You can't do that with Excel. Transformations are done with expressions in the so-called general refined expression language or in Python, which makes it extremely powerful because if you're able to program with Python or let a large language model program for you in Python, then the opportunities in OpenRefine are almost infinite because you can use Python within the interface of OpenRefine. It runs in, as I said, in the browser, but it's local and it's a local web server. So I would like to see OpenRefine just as an interface to what's actually a programming task. So in the background, all of these tasks that we're going to do now, they're actually just written out programming syntax that you could easily and also do with Python and most things with other programming languages too. So what I want you to do is I'll send you a link to to some sample data that I have prepared. But if you want, you can use your own data set as well as if you have CSV or Excel. Doesn't really matter. As I said, I really just want you to try the tool out. There's no need to excel in anything or do the exact same tasks now. What I want you to do is to explore the tool a little bit. So once you downloaded this CSV, then you go to choose the file. Where do I have it? What's it called? Processing. Okay. I have to download it myself again to find it. Okay. So I'll do now the exact same thing that you will have to do. I download it now. Go to OpenRefine, open the file. It's here. Open it. Click Next. Make it a little bit bigger for you. It's not working. I think I have to restart my OpenRefine. Sometimes this happens when it's a little buggy, but it should work if you reopen it. Maybe I got too many tabs open. Let's try this. Yes. Okay. So what you see here now is a preview of our data. We can set the character encoding. You'll see here, I'll just keep that to UTF-8 that most of the time you want that. As I said before, you need to define columns is separated by what? Normally a comma, but it could be, whichever separator, but it wouldn't work with this one. See, but it is a comma. Parse the first line as column headers. If you have two lines of headers, sometimes this happens and you have to tell it here. Normally, everything is just fine as it is. And you could name the project. You give it some tags if you have really a lot, but you don't need to do it now. Just leave this blank, create project. And then it's creating a project. And it says done, yes. And here we are. I hope you're all at the same situation that I am now. So what you see is the first 10 rows of 47. Normally with OpenRefine, what you would do is work with a lot more data, thousands, tens of thousands of rows, so you couldn't even visualize them for your eyes to see, but they're there, like in a database. In this case, we could easily make it all rows visible for us, and yeah, see them all and be able to scroll through them. So what we want to do now is we want to do stuff with OpenRefine that we would normally do with any programming language. And what we always want to do, and all programmers are doing this with string data, is we trim it. The function is almost in all the languages is called trim. And here it's called trim leading and trailing white space, because this is exactly what it does. It trims leading and trailing white space. And we always want to do that with our data, because no one wants a leading white space or trailing white space. It's just not useful in any tabular data set. What we also want to do is look at the cases. We see here, that's lowercase, that's title case, that's uppercase. Just doesn't look so good if a data set is written in so many mixed cases. So what OpenRefine can do for you, I'm going to leave this open for a moment. You click in the column here, go to Edit Cells, Common Transforms, and then there's some of those common transforms ready for you. For instance, to title case. In this case, that's what we want. To title case, and you see looking better. What we want to do now is we do our first facet. And a facet now, we know that we're working with text, so we're doing a text facet, gives us an overview of all the data that's in one row. And now we have the option to sort it alphabetically with name or count it. And see now we have 2 Grover Clevelands and 2 Woodrow Wilsons. And what we could do now is cluster them together. So the same values, and see if I have some duplicates or other problems with my data set. And I click on cluster. And I have now some options, some methods of clustering similar looking strings. For instance, the metaphone is one of those functions that just cluster similar sounding things together. So what we see we have Barack Obama twice here, written once with CK, once with K. And I think the CK is the correct, so we will choose to merge it into Barack Obama. So the next one, again, we will have to use our human brains, our knowledge, our world knowledge to know that these two people, although they sound very much, the string sounds very much alike, are not the same people. And so could happen also with people who are just named exactly the same. So we have to be very aware of what we are clustering together, what we are merging. We don't want to merge the same people or whichever data we're using in our data set, always looking at it with our human world knowledge. Am I really doing the right wrangling task at the moment when I merge seemingly same things, but maybe they're the same string, but different concepts, like we had before with queen. Just because the string queen is the same doesn't mean the meaning queen is the same. So if I have a data set with 10 different meanings of queen, Better not cluster it together if this is my use case. So in this case, I can cluster Barack Obama because I know there's only one Barack Obama as being a president. I'm not going to merge the Bushes. And then close it, count again, and then see we have still 2 Barack Obamas. I don't know why this happened. Did I? Got it. Oh, sorry. I only chose this now. And cluster again. No, I actually clustered it. I don't know why I still have 2 Barack Obamas. Oh, of course, I have 2 Barack Obamas still. But I changed.
Christian, we can hear you now.
Yeah. What was the problem? I can't hear you now. We're back. Okay, great. I'll show the clustering again. Let me redo it, undo it. So I click on cluster here, and then I can change the different functions. And if you, sorry again, I included. Now, what happens here if I include just one, then of course the button cluster would only concern the one I chose. So I have to choose, make sure that I see all the rows, then cluster, and then choose a function that's fine for me. And to find out which function works for your data set, you really have to look into the clustering methods, like the Levenstein distance or Daiichi-Mokadoff. It's all different algorithms. And you will really have to find out yourself which algorithm fits your data set best. So I'm just choosing for now just to show you the Metaphone algorithm. So we have Barack with CK and K and cluster them together, and we're merging them to CK. And I say merge and close. Anyway, I don't know. That's happened before because I am losing. It just told me that I'm losing what I did before. Okay, now I clustered Barack Obama, but we still have him twice. And what we can do now is we leave this text facet, get access to all of them again. And use a duplicates facet. So I'm leaving that open for a second so you can see facet, customized facets, duplicates facet. A lot of the times we have duplicates in our data set and want to get rid of them. So OpenRefine made it easy for us to find that with one click of a button onto a duplicates facet. And once I click it, I see true for 6 people. And then I have to be careful here again, close look with a human eye, with a human brain. Are these real duplicates? And I see 2 of those. Yes, they're real duplicates because they have the same serial number, 44, 28, and there's no differences in any other cells. But Grover Cleveland is just another president. It's not a duplicate. It has a different serial number as well. So what we want to do is we could flag those 2 entries, and if I do this more often, I could flag whichever entries I want to delete, not just duplicates, but any entries that might be wrong. And then I leave this again and say all, and then facet by flag, for instance. Get my, if I click true, I get my 2 duplicates, and then I can say, remove matching rows. Because that's what I want to do. I already flagged them as false for some reason, and our reason is duplicate. And I can just remove them by clicking remove. Now, remove the facet again, back to rows, now back to 45 rows. See, text facet again, count, and we're down to 2 Clevelands, but that's fine. And everything else seems okay. Now, there's not a lot of time left, so I'll have to go through the other things more quickly that we could do with the data. But as I said, you really have to play around with yourself, and just you can also ask ChatGPT to explain to you what can be done with OpenRefine. And the other thing we could do is not just we can work with text as we did now to clean this. We can work with numbers and replace stuff and make them a real number data format, and then have a numeric facet that lets us choose with this kind of timeline tool. Same with date formats, and then we can translate them from one date format to the other, like ISO format or a human readable format, American, British, Czech, German way of writing out our dates. And so you can play around with dates. But what I really want to show you, and what's really important, that you get an idea of what you can do with OpenRefine, is the reconciliation for I leave you for lunch. So reconciliation it can be translated with alignment, matching. It's a mechanism that lets you connect your database to other databases. And one of those databases that is added by default is Wikidata. I hope most of you have heard of it. Wikidata is basically the Wikipedia for machines. So it knows things about Ostrava in a very structured way, in the form of RDF. These are statements, triple statements. So it says Ostrava is a statutory city in Czechia, is a big city, and so on. It has a logo, it has an image, an official name, a native label, blah, blah, blah. It has all kinds of these statements. It is the capital of Ostrava city district. And these information, what we can read here now for the human eye again, in the background, is all machine readable. In contrary to Wikipedia, which is only human readable. So Wikidata, Wikipedia for machines, has more data than Wikipedia, but it's easy to remember it as the Wikipedia for machines, community-based. I'm not going to go into detail here because it's lack of time. But it's a great database for world knowledge. So we can connect now our local database with Wikidata to get way more information about our presidents than we had before. So what we want to do is we got rid of all the facets. And also I want to show you this. This is the overview. I have it in the slide. So here you can see all the services, the reconciliation services that are online. It's not just Wikidata. it's all kinds, like performing arts, Switzerland, all kinds of databases. I don't know if there's anything from, nothing from Czech, but if you might know via virtual national authority file or SID ID, probably a lot of you know. All kinds of different databases that are out there can be connected. And what we want to do is go to reconcile and start reconciling. And you'll see here my Wikidata English version is already included. I could include any other service by just adding the URL that I can find here in this overview, this URL, and add it and work with it. But we're going to see what happens with Wikidata. Click next. And then we say it's fine. This is a human that we want to, the type of the data we want to reconcile is human, auto-match with high confidence, and start reconciling. So what's happening now is no AI or LLM and guessing and what this is and semantically enriching it, but a pure string comparison. So you have to be aware of that. So it needs human intervention because there's so many strings that have more than one meaning and hence more than one concept in Wikidata. So there's a lot of disambiguity that we have to filter out. Now, in this interface, we have to do it manually with our brain and our hands. But there is ways, of course, to do this algorithmically with Python code, but this gets very complicated because, again, this is now semantic enrichment, which is way more difficult than syntactic transformation. So we'll see, some of them have been matched, but most of them have not. So we would have to do it manually. We find out by hovering over it. And you see, okay, this is the president I want, and click on this. John Adams is the one I want, and so on. So you would just go forth and get the presidents matched. So you want to have them all matched. Once you have done so, you don't have to do that now. What you now have is, if you hover over it, you click on it, you go right to the Wikidata site that's human readable for George Washington. But what's more important is you have all the information now available in machine readable format. And so what you can do is you can go to edit column, add columns from reconciled values. Leave this a little bit so all of you can see it. And once you click it, you already get suggested properties, but what we have now available is all the data that is in this database that we connected it with. And what we have now is all the data in Wikidata. For instance, it has the place of birth from all the presidents, and I click OK. And then all of a sudden I get a place of birth from the presidents. What I can also do is all the properties that are in there now in the data. I type in death and I get cause of death. Interesting. What was the cause of death of these presidents? George Washington died of acute laryngitis. Now, what I also, not only do I have now the connection from George Washington to his cause of death, but I also have all the connections now from this disease. So what I could do is, again, get more reconciled values from this disease. I don't know, what does this disease have? I don't know. It has proteins, yes. Don't work here. I click here on this so I can see which statements the disease has. It has a ICD-10. That's known the the standardization for diseases. And what I could do now, ICD 10 ID. Yes, okay. And we get the IDs for these diseases and so on. So what's happening here actually is I'm building a huge graph of knowledge, a knowledge graph, because once I start connecting it with different databases, I connect a lot of different knowledge that I started with my single small data set. And by connecting it to what's already out there, I get this whole graph of knowledge. And now this is a huge advantage I have, and I want to make sure that you're aware of that the possibility is out there to get this knowledge graph. It's not too difficult to get to there in most of the cases. And it's highly useful for a lot of the data sets. And we can also connect our own data sets, our own databases, use produce our own reconciliation services that we can then input there and go further. So there's a whole level of opportunities we get once we get into this whole world of reconciliation. And of course, we can also think of integrating large language models in there, because this is a tedious job for us to choose which one is a president and which one is an American athlete, just happens to have the same name. This is, of course, also a task a large language model could do for you. But then we're in the world of APIs and programming, and this is the time for a whole other workshop. But what I wanted to do today is, as I said, give you the bigger picture. And I really want to recommend you that you really look at the bigger picture and see what's out there, see what you can do with large language models, with the tools that are out there, see what's useful for your domain, especially, and for your work field, so to say, your colleagues, and your responsibility as a data steward. And I think that's, if you get this idea and inform yourself about those technologies that your colleagues will need, then you're a very good data steward. And that's where I want to leave it, and open for some questions or comments. And I have to apologize that I was a little fast, but 3 hours is just not enough for this amount of information that I wanted to give you.
Thank you, Christian. We are not asking some questions. So it seems we are going to write the questions in the chat.
Yes, that's exactly what it does. Yeah, exactly as you wrote it. And all kinds of other databases. There is not, of course, not services for all of the databases out there, but you can connect them. What limits me to connect all of them? Yeah, there is no services for all of them. You have to write them yourselves, and that's not as easy as you can't do it within minutes. I have to work a little bit to get the connection going. That is the big limitation. And of course, semantic matching is not a trivial task. I mean, it's trivial because I have world knowledge about some American presidents here, but you can imagine what happens if I have thousands of data points that I'm not sure of. Then I really need artificial intelligence. I'm not sure what you mean. If you connect more of them, you can't connect more than one database to one column. That's also a limitation. So I can't connect another database to the same column. So this would not work. I could do it with another column, and then I could, of course, duplicate this column, split into several columns. I can just easily duplicate the column and then have separate databases, but it can get messy. It just depends on your use case. And searching, the only thing is that normally you wouldn't want to do this manually. So you will really, in a sophisticated research project, you would not use OpenRefine as the interface, but you use the API. And it's, well, I mean, with small data sets, yeah, of course, the interface is very useful too. Upload data from, yes, of course. I'll show you. You can upload almost anything. No, what can I see? Oh, here. You see all kinds of data: JSON, XML, RDF, Google data, documents, Excel, CSV, TSV, databases can be connected. MySQL, Postgres. You just paste data, web addresses, you scrape data. So there's really not a lot of data you cannot upload into OpenRefine. Most of the data you can. Okay, if there's no more questions, then thank you very much for listening, and I hope you learned something. If you have any questions afterwards, don't hesitate to just write me an email or contact me in any other way. This is so this is how you can contact me anytime for any inquiries. And have a wonderful another 2 days, the afternoon and tomorrow in your summer school. And have a good time. Thank you.